Okay, how are you today? What we're going to be doing is talking about vector and scalar quantities. This is a review for the test for Chapter 3. So vectors, we said, are quantities that have both magnitude and direction associated with them. Something like a velocity or an acceleration that has a certain quantity, like 5 miles per hour north or 5 miles per hour east. It's giving a direction and also a quantity associated with the direction. Scalars, on the other hand, are just the magnitude, so we can think of scalars as simply a number. For example, the number of books on a bookshelf, number of desks in a classroom, the number of birds sitting in a tree, the types of things that we could classify as scalar. So you need to know the difference between scalar quantities and vector quantities. When we talk about vectors and adding vectors, we need to know how to add two vectors together. So if we have a vector, and a vector always has a direction, so we designate a vector. Here's vector A. All right, and that's the magnitude is A, and the direction is this way. And we wanted to add another vector, let's call it vector B. We would take the two and we would get a result, R. Now notice in this case, if let's say for example the magnitude for vector A was 8 and the magnitude for vector B was, let's say, 3, then the magnitude of vector R, which was the resultant of adding A plus B, is going to be 11. So A plus B as a vector is equal to vector R. Sometimes we designate little arrows above these things to say that we're talking about vectors, but we haven't done too much of that. Now that's fine and good. So if the vectors are in the same direction, we can simply add them together. We can subtract them also. If you have something going like this, where this is 8, and then we want to add a vector that's opposite to it, let's say that's a magnitude of 2, then we could do that also, and in this case the result is going to be 8 minus 2, which is going to be 6. And for example, let's say if we had over here let's say a sailboat sailing on the ocean at 8 miles per hour, and the wind is blowing against him, a gust of wind comes against him at 2 miles per hour, then the boat's actually only going to be making its headway at 6 miles per hour in that direction. What happens though if we have a vector like this, vector A, and then we have another vector going the opposite way? Let's say we have another vector and we want to add a vector B that's going down. So vector A goes to the east with some magnitude. Vector B is heading south with some magnitude. And we want to know, the question is, what's the resultant vector going to look like? What is R going to look like as A plus B? So suppose we give some numerical example. Let's say we have a vector here of, let's say this is 8, and I want to add a vector going downward of, let's say, 5. All right, so what is this, these two vectors here added together, going to look like? And let's continue up here. And I'll do it in yellow now so that we don't get confused. So I could do it in one of two ways, and this is what you have to pay attention to. The best way that we've been working is to say, okay, let's set up a little coordinate system, an XY coordinate system, where this is X here, as it always is. And we're going to then let's put our vector representing 8 along the x-axis, because it's heading that direction, and we'll say that's 8. And there's another one going south at 5, so we'll put the 5 over here. So this 8 is associated with the x component, and this 5 is heading in this direction. So our result, we draw the little box, and our result is going to be going in this direction here, R. And we'll say that R then we're going to have obtained by the Pythagorean theorem, R squared will be equal to 5 squared plus 8 squared. So R will be then the square root of 5 squared plus 8 squared. And let me just redraw that up here so we could see what we're doing. This is 8, this is 5, and this here is my result. And there's going to be some angle that the result is going to be going at, all right? So we already figured out r down here. R is simply the square root of 5 squared plus 8 squared. But we know that the tangent of that angle theta is going to be opposite, which is 5 over 8. This is the opposite side, and that's the 5. This is the adjacent side, and that's the 8. We don't want the tangent of theta, though. We want the theta itself. We want the actual angle, not the tangent of the angle. We simply want the angle. So in order to get the angle theta, we have to, on our calculator, take the inverse trig function for tangent, the inverse tangent function of 5 over 8. And if we do that, we set our calculators in degree mode so we don't get the wrong answers, and we'll get that angle in degrees. Okay? This minus 1 does not mean take the reciprocal. All right? It's simply a notation used to denote inverse tangent. The other way that people can do this, and that sometimes you see it in the book, and this is just, I want to point this out because you need to know this also, is if I were to take my 8 vector like that, instead of drawing the coordinate axes like I did over here, instead of doing it that way, I could take 8, I could take my next vector of 5 and put the tail of the 5 vector right on the arrowhead of the 8 vector and draw my 5 vector. So I have my 8 vector with a magnitude of 8 looking like that, and then I have my south vector here with a magnitude of 5 looking like that. And notice I put the tail of my 5 vector at the arrowhead of the 8, and then when I do that, my result is going to go from where we start right here at the tail of the first vector, and it's going to be drawn to the arrowhead of my second vector, and that's my result. And you see that result here, and that angle here is going to be identical to what we did right over here, except that what you need to know is the result of this 8 plus this 5 has got to go from the tail of one vector to the arrowhead of the other vector. So let me just tell you what, let's do this. Let's put something right over here. Last thing in this video, if I have A and I have B, then what I've got over here as my result is going to be A plus B, geometrically. All right, talk to you next time. In the next video, we'll continue the review for the test.